Good morning all. In the previous few videos, we were discussing the 6th module of Geotechnical Engineering 1. We started off with the compaction of soils. We discussed the standard Proctor test, the modified Proctor test, the heavy compaction test, and based on the results, we discussed what OMC, optimum moisture content, is, what maximum dry density is, what zero air voids line is, and we moved on to the control of compaction and field, and then we discussed a few problems based on the compaction test. The second portion of that module was about stability of slopes. We discussed what the different failure types are. We started analyzing stability of slopes with friction circle method, Swedish circle method, phi zero analysis, etc. And then we discussed the factor of safety and the Taylor's stability number and stability charts. In this lecture, we'll discuss another few problems based on compaction and stability of slopes. The first problem is quite a simple one and is based on compaction. You're asked to find the theoretical maximum dry density of a sample of soil with specific gravity 2.7 and optimum moisture content 16%. Now we know that the maximum dry density is a case of dry density, and hence we can apply rho d equation is equal to G by 1 plus E into rho W, where G is the specific gravity, E is the voids ratio, rho W is the density of water. Now, since we are not given with E, the voids ratio, we can replace E by an equation connecting SE and WG, which means we can write E is equal to WG by S, but S will be equal to 1 for a fully saturated case, which is a theoretical maximum dry density, right? So I can rewrite the equation as G by 1 plus WG into rho W, because S is equal to 1. Now in this equation, we know G 2.7 is given, you know W 16%, which happens to be 0.16, rho W is equal to 1 gram per cc. So when you substitute rho W is equal to 1 gram per cc, you will get the value of rho D in gram per cc, right? So it turns out to be around 1.88 gram per cc. Next question. You have a slope to be constructed at an inclination of 30 degrees with the horizontal. You're asked to find the safe height of the slope for a factor of safety of 1.5 and a soil whose cohesion is 15 kilopascal. Unit weight of the soil is given 19 kilonewton per meter cube, and the angle of internal friction is 22.5 degrees. So it's quite clear that the soil is C5 soil, and you are given with the factor of safety 1.5 for the design, and the slope angle is given 30 degrees. So your question given is to find the maximum height, the safe height at which a slope can be constructed. Now we can solve this using Taylor's stability number Sn given by C by Fc gamma H. C is given as 15 kilopascal, factor of safety is given as 1.5, gamma is given as 19, and H is unknown. So we need to know the stability number Sn, for which we are given with I is equal to 30 degree and phi, angle of friction, is equal to 22.5 degrees. So from the stability chart, based on I 30 degree and phi 22.5 degree, you can get the value of stability number as 0.046. You can refer back to the stability charts or the table given in any of the standard textbooks. So once you know Sn and once you know this equation, the only unknown turns out to be height H, which when solved gives a value of 11.5 meters. Next question. A trial slip surface AB, as you can see in the figure, is given with the geometry of radius 19 meters and the weight of the soil wedge is given as 2050 kilonewton. The soil is pure clay with cohesion 55 kilopascal. You are asked to find the factor of safety. Now, if you take a look at the geometry, you can see that ADB is the slope that we are interested in, which is assumed to be failing along the line AB, and ADB, the soil mass, has a weight of 2050 kilonewton. A and B subtends an angle of 64.5 degree with the assumed center of the circle, part of which is AB. 19 meters of radius given, and the weight 2050 kilonewton is acting at a lever arm of 9 meter away from the center. Now, with the given geometry, you can find the length of the arc AB. Radius R is given, theta subtended by the arc is given, so based on which you can get R theta into pi by 180. Now pi by 180 is added to convert that into a radian format. So 19 is a radius, 64.5 is a degree angle converted to radians by a factor of pi by 180. So length of the arc AB turns out to be around 21.39 meters. Knowing the length of the arc AB, you can find moment causing failure and moment resisting failure, get the ratio to find the factor of safety. Now, moment causing failure, like we discussed, is equal to the weight multiplied by the lever arm. 2050 kilonewton, when acted at a lever arm of 9 meter, will have an overturning moment in the clockwise direction with respect to O. So the value MO is equal to 2050 into 9, which is 18450 kilonewton meter. That is a moment which tries to fail the slope downward and outward. Now, the moment resisting failure is equal to CLR. C is a unit cohesion, L is the length of the arc that we have just now determined, R is the radius. So in short, you have C unit cohesion acting all along the length of arc AB. So you multiply C by L, what you get is the total cohesion, which is acting at the lever arm of radius. So CLR is a value of 22353 kilonewton meter. That is a moment which resists the failure. In this particular question, you don't have 5 components, so every force that's trying to resist the failure is just contributed by C cohesion. Next step is quite simple. You take the factor of safety is equal to MR by MO, with resisting moment by overturning moment. So you divide 22353 by 18450, and the value that you get is 1.212. We'll move to the next question, which is quite similar, very similar in fact. The only difference turns out to be the geometry. The figure shows the details of an embankment, again made of cohesive soil with phi 0 and C30 kPa. Unit weight is given as 18.9 kilonewton per meter cube. You're asked to find the factor of safety. The only difference here is that the geometry is different and C is different with the unit weight different. The fundamental principle remains the same. So same thing, you find the length of the arc AB is equal to R theta. In this case, R is equal to 9 meter. Theta is the angle subtended 70 degrees. You convert that to radians, and the value that you get for the length of the arc is around 11 meters. Now, to find the moment causing failure, 360 kilonewton is acting at a lever arm of 5 meters. So MO is equal to 360 into 5, which is 1800 kilonewton meter. The moment resisting failure, MR, is equal to C into L into R. C, the cohesion, is given as 30 kilopascal. Length of the arc, we obtained it as 11 meter. R is a radius given as 9 meter. You simply multiply it, 30, 11, 9. What you get is 2970 kilonewton meter. Factor of safety, you take the ratio MR by MO. 2970 by 1800, which gives a factor of safety of around 1.65. So compared to the previous example, this geometry of slope seems to be a bit more better in terms of safety. You have 1.65, which is greater than 1.2. Next question is again based on slope stability analysis, but with a different approach. You are given with the slope of height 15 meter and angle 35 degrees. Question: an embankment is inclined at 35 degrees at height 15 meter. The angle of internal friction or shearing resistance is 15 degree. Cohesion is 200 kPa. Gamma unit weight is 18 kilonewton per meter cube. You are given with the stability number 0.06, from which you are asked to find the factor of safety with respect to cohesion. Now, based on the geometry, beta or the angle I that we have represented in the theory is 35 degrees, height is 15 meters, gamma is equal to 18, C equal to 200, phi equal to 15. Now we know that the stability number Sn is equal to C by Fc gamma h. The value of Sn is already given in the question and is equal to 0.06. So in short, C by Fc into gamma substituted with 18, h is given as 15. So this is equal to Sn 0.06, from which we can write C by Fc is equal to 0.06 multiplied by 15 multiplied by 18, which gives a value of 16.2 kilopascal. In short, C is already given in the question as 200 and Fc is the unknown. So you divide 200 by Fc and the value that you get is equal to the factor of safety, and the value is 12.3.